Crossing hundreds of millions of miles of empty space to reach Mars is a staggering achievement. But reaching the planet is only the opening maneuver. The moment the crew enters orbit, they pivot from a problem of transportation to a pure, uncompromising problem of survival. Down below is an untouched, irradiated vacuum. The surface temperature averages -81 degrees Fahrenheit, and the atmosphere provides zero breathable air. Human biology is entirely incompatible with this environment. To make matters more difficult, the distance creates a severe communication lag. A simple distress call can take up to 22 minutes just to reach Earth. Calling for an immediate rescue is impossible. Look at this timeline chart comparing emergency scenarios. It takes roughly 7 months for Earth to physically deliver a payload to Mars, but a critical failure in life support depletes breathable air and water in days. The math is unforgiving. Long before a resupply ship clears Earth's orbit, the Mars reserve slams into zero. A ticking clock starts the second they arrive. Staying alive means the crew has to execute a sequential, flawless engineering plan, using only what they have on hand. Earth cannot save them. The very first step is getting through the atmosphere. Mars has just enough air to create intense friction against a falling ship, but not enough to easily slow down a heavy payload. The lander has to bleed off thousands of miles per hour of velocity, firing retrorockets to combat the planet's gravity, until the landing struts finally slam into the rocky surface. Once on the ground, unpacking equipment takes a back seat to the single most urgent priority, establishing a pressurized, physical barrier between the astronauts and the dead landscape outside. They need this shelter immediately to block the lethal barrage of cosmic radiation passing right through the thin atmosphere and to hold in an artificial pocket of oxygen. This cross-section shows how those early habitats are engineered. The core is a pressurized bladder that traps breathable air inside. Surrounding that is a dense outer shielding, often utilizing frozen water or tightly packed Martian dirt, to absorb incoming solar radiation before it hits human tissue. Locking the airlock on this first structure gives the crew the one resource they need above all else: enough time to solve the next problem. With the clock temporarily paused, the mission must shift to in situ resource utilization, or ISRU. This simply means manufacturing what you need from the local environment rather than unpacking it from Earth. The crew deploys rovers to drive heavy, automated drills straight down through the dusty red crust, boring into the surface to reach the thick layers of ancient ice buried below. Pulling that frozen water out of the ground is the bedrock of the entire ISRU strategy. Everything else relies on it. Through electrolysis, an electrical current breaks melted water apart into separate streams of hydrogen and oxygen. The freed oxygen pumps directly into the habitat. The crew breathes planet-manufactured air. The hydrogen combines with atmospheric carbon, synthesizing methane fuel for the waiting rocket. By mastering this chemical loop, the crew eliminates the threat of empty tanks. Mars becomes a self-replenishing outpost. Air and fuel are secured, but humans still have to eat. The next sequence requires the crew to step out onto the surface and build dedicated, pressurized agricultural zones. You can't just plant seeds in the dirt. Martian soil is saturated with toxic chemicals called perchlorates, and it completely lacks the decaying biological matter that Earth plants require for nutrients. To compensate, engineers have to build highly controlled greenhouses. They wash toxicity from the soil, introduce imported microbes, and tune artificial LED arrays to the exact light spectrums necessary to trigger photosynthesis. The result is a burst of vibrant green life, with stems and leaves rapidly expanding inside a sterile alien environment. A successful harvest closes the biological loop. The colony generates its own calories and severs its reliance on the distant, vulnerable supply chain of Earth. Fast forward the timeline, and we can see how these isolated victories stack on top of each other to create something massive. Here is a node map showing the colony's architecture. It starts with 3 simple modules: a habitat, an ISRU extractor, and a greenhouse. Because they are modular, they are designed to be perfectly duplicated. Over decades, those 3 core units are copied and connected hundreds of times. The map expands into a dense, interlocking grid. It creates a robust infrastructure capable of supporting thousands of residents. The daily routine shifts from a constant fight for baseline survival to the actualization of a permanent society. people focus on research, art, and building families, rather than rationing oxygen. The barren Dust Bowl becomes a sprawling, illuminated city, humming with life and energy under the glow of a Martian sunset. A thriving human civilization on Mars doesn't require magic. It is built strictly through sequential, solvable engineering steps.